Hi everybody, it's Mrs. Curtin. I just wanted to go over how to determine the type of reaction and then how to predict the products. So the first thing is how to tell what type of reaction you have. Okay, so there are 5 types of reactions. The first being synthesis or combination. Okay, and so you can, like the general format for this would be A plus B yields AB, where you have 2 reactants and then you have 1 product. And then to form the product, okay, so if you were to predict the product, you'd have to do crisscross between the 2 reactants. All right, so to show you an example of this, I will pull up your POGIL, and this is going to be a POGIL in Model 1. So if you look here, you have calcium and oxygen as your 2 reactants, and then to predict the product, okay, I know calcium is a +2 charge, oxygen's a -2 charge, so they cancel. The product here is just CaO as a result, calcium oxide. Now you may notice that it's not balanced. Okay, so then I can add a coefficient to balance the oxygens. Now I have 2 calciums, then I'd have to put a coefficient there. Another example we can do with letter B. Okay, I have 2 elements as reactants, so I know the only thing they can do is combine. So I have sodium and nitrogen, and I do crisscross to get Na3N. And to balance this, you'd put a coefficient of 2 in front of the sodium nitride to balance your nitrogens. That leaves you with 6 sodiums. Then to do crisscross again here, aluminum is +3 and fluorine's -1. So you get AlF3. Then you have a 2 and a 3, so you would need to put the subscripts in as such. So that's synthesis or combination reaction. The next type of reaction is going to be decomposition. All right, so to tell that you have a decomposition reaction, it's going to look like AB yields A plus B, so the opposite of synthesis, where you have 1 reactant and 2 products. And then to predict, so to get the product, you're going to follow the rules. I'm not going to write them all out here, but they will be given to you on any type of assessment. Okay, so in looking at those rules, okay, the rules I'm talking about are that if you have a carbonate, like it's where the polyatomic ions really come in, is where you need the rules, because if you just have a binary compound, you just separate it into the 2 elements. That's how that would decompose. When you have these polyatomic ions, it gets more complicated. So if I have a carbonate, it gives off carbon dioxide and then an oxide compound. The oxide compound would be formed by doing crisscross between the metal in your initial compound and oxygen. So that's how I got Al2O3, because aluminum was the metal in the initial compound, then it would form with oxygen. Same thing down here with sulfates, you get sulfur trioxide and then an oxide compound. Notice the oxide compound is with the metal from the initial compound. Hydroxides are going to produce water and an oxide compound. Again, notice how the oxide compound has the metal from the initial compound. Chlorates are going to give off a chloride compound, so similar to the oxide compound, you do crisscross between the metal and chlorine, and then you're left also with oxygen. Then again, a binary compound is simply just going to split into the two elements. So here, you notice that we have chromium 3 carbonate. Okay, so a carbonate, if I look back at my list, gives off carbon dioxide and an oxide compound. So I know CO2 is one of my products, and then plus the oxide compound. Chromium is my metal, and I know it's chromium 3 in this case because carbonate's -2. I have 3 of them, which is -6. So the +6 is going to have to be divided amongst the two chromiums. So I do chromium is +3, oxygen is -2. With crisscross, that becomes Cr2O3. Okay. And then to balance this, okay, we can start off by putting a 3 in front of the CO2 because I have 3 carbons on the reactant side. That gives me 3 carbons, 6 oxygens plus these 3 oxygens, which is 9, which is the same. And then I have 2 chromiums, so that does balance. Here, the sulfate is going to give off sulfur trioxide and the oxide compound. In this case, I have iron 3. So it'd be Fe2O3. Balancing wise, looks like we're going to put a 3 here. That's 9 and 3 is 12, which is what I have, so that looks to be balanced. I'll let you guys follow the rules for 10 and 11. 12, again, is a binary compound. So with the binary compound, that's just going to split up into copper and oxygen. But oxygen, remember, is diatomic, so it does need the subscript 2. So I would need to put a 2 here and a 4 here to balance the equation overall. So that's decomposition. Our third type of reaction, let me just see if I can excuse me, scroll in a little bit here. Okay, so our third type is going to be synthesis, or sorry, not synthesis, it's going to be single replacement. Okay, single replacement is going to take the form A plus BC yields AC plus B if the single element is a cation, because notice how A replaces the cation. Or it could be X plus YZ yields YX plus Z if the single element is an anion. Okay, because the single element is going to try to replace whatever element in the compound it's similar to. I know it's single replacement when you have one element plus one compound giving you one element plus one compound. Okay, to get the products, first you have to check the reactivity chart, which I'll show you in a second. To see if this single element is more reactive than what it's trying to replace. And if it is, you're going to do crisscross between the single element and the other ion and write what was kicked off by itself, checking if it's diatomic. And then what you'll do if the single element is not, you're just going to write no reaction, because that's possible. Okay, so let's look at the single replacement in your POGIL. Okay, so if you look here, okay, they should have arrows. Okay, this is the reactivity chart, okay, which is not something you have to memorize. If you look at equation 10 here, zinc is a single element, and it would form a cation, so I know it's going to try to replace copper since that's the cation in the compound. So I would look at the chart. Zinc is here, copper is here. And notice how it says reactivity decreases as you go down. That means zinc is more reactive than copper. And that means this reaction will take place because the single element has to be more reactive than the element it's trying to replace in the compound. And again, I knew zinc was trying to replace copper because they would both be cations. Additionally, they're in the same column. That's another trick you could use. So if you look, zinc kicked out copper. So copper is by itself, and now zinc bonded to sulfate. And I did crisscross to form that compound. Here, chlorine would be an anion, so it would kick out bromine, because bromine would be the anion. And I know chlorine can, because chlorine is higher up on the chart than bromine. So let's do an example. Sodium plus magnesium chloride. Okay, so first, sodium I know would form a cation, so it's going to try to replace the cation in the compound. Sodium is here, magnesium is here. So sodium is more reactive than magnesium, so this will happen. So sodium is going to replace magnesium, kick magnesium off by itself. Magnesium isn't diatomic, so I can just write it as Mg. Then I have to do crisscross between sodium and chloride. So that's +1 - 1. And that's how I got the compound. Now, to balance, I would have to put a 2 in front of sodium chloride and in front of sodium. Then for 6, F would be an anion, so that would replace iodine. And I look, fluorine is more reactive than iodine, so this will take place. Okay, so fluorine's going to kick iodine out. So iodine's going to be by itself. Iodine is part of our diatomic, remember Brinkelhoff? So I is going to have a subscript of 2. Magnesium is +2, and fluorine is -1. So I get MgF2. And that ends up being balanced. Our next type of reaction that we're going to see is double replacement. Okay, double replacement takes the form of AB plus XY. Yields AY, notice how the cation stays written first, plus XB. Okay, where you have 2 compounds that switch partners to form 2 compounds. And then to get the products, you're going to go the outside are going to form. Okay, so cation 1 will crisscross with cation 2, or sorry, anion 2, and then you'll do the inside, where cation 2 is going to crisscross with anion 1.